Today we're learning how to take the derivative of functions that are in exponential form. That means we have a number raised to a variable power. In the graph that you're looking at, this blue line is the graph of y equals e to the x. So that's the types of functions that we're talking about taking the derivative of. And today we're only going to focus on when the base is the letter e. Now, this red function here, just for your information, is the function y equals the natural log of x. We talked about that last week, but we did not actually ever look at a graph. And if you look at these two graphs, you see that they are reflections of one another. That's just a way to recognize that they are inverses of one another. As we move forward, derivative of something that is e to a power. Well, the derivative for e to a power is something that's very easy to understand. The derivative of e to the x power is e to the x power. And just like with our other rules with logs that we used last week, if that thing that we are raising e to is something other than x, if it is a function such as u, then the derivative would be e to the u, e to that same power, times the derivative of that power. So just like with when we're taking the derivative of ln of x, the derivative is 1 over that argument times the derivative of that argument. The same thing if our function is e to the x, the derivative is e to that argument times the derivative of that argument, which if it's x is the number 1. So relatively simple rule to understand. Let's look at an example. If we have e to the 5x plus 7 power, then when we go to take the derivative, then the derivative is going to be e to that same power times the derivative of 5x plus 7. So since 5x plus 7 is the power, the derivative of that is 5. So our final answer would be e to the 5x plus 7. Another example to look at, if you will, stop the video at this time, take a moment and see if you can determine what the derivative of this function is. We know it's going to be e to that same power, and now we must take the derivative of 7x. So you may want to come over 7 over x. You may want to come over onto scratch paper and rewrite that. That's 7x to the negative 1. So if that is our function, then our derivative of that is going to be negative 7x to the negative 2. Or we could rewrite this as negative 7 e to the 7 over x power over x squared. That would be our final derivative for a function such as this. And let's take a couple of more examples. This example says find out where it has a horizontal tangent line. Now if you remember a horizontal tangent line, that means that the slope equals 0. So we need to find the derivative of this function and set it equal to 0. Well, how do we find the derivative of this? Notice that we've got x times e to the x. So then we need to use the product rule in order to find this derivative. The product rule says first times the derivative of the second. The derivative of e to the x is e to the x, plus the second, e to the x, times the derivative of the first, which is the number 1. So now we need to set that equal to 0. Well, when is this thing equal to 0? How do we solve that? I would factor out an e to the x, so we get e to the x and then x plus 1 equals 0. Since these two things are multiplying together, then that means one of them has to be 0, so either e to the x equals 0 or x plus 1 equals 0. And if we solve out the right one that I wrote down here, we get x equals negative 1. So negative 1. Let me see if I can erase that. Alright. But what happens on this side over here when we're looking at e to the x equals 0? Well, if you'll go back to the first slide that I showed you, this is the graph e to the x has a horizontal asymptote at x equals 0. That means this never happens. So e to the x is never equal to 0. So the only place where this has a horizontal tangent line is when x equals -1. Now if we go back to the directions, it said find the points where f has a horizontal tangent line. That means for a point we want -1 and then whatever the y component of that is. So we need to go back to our function and plug -1 in, and if we do that we get negative e to the -1. So we could write that as a fraction as -1 over e. So the only point that has a horizontal tangent line is -1, comma, -1 over e. Taking derivatives using the with exponentials is not that difficult. Just remember e to the x, the derivative of that is e to the x. If x is something other than x, if it's a function, you're going to have to use the chain rule.